This is Chapter 7, Section 3, Triangle Similarity, and then we're using angle, angle, side, 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 and side, angle, side. Your objectives are to prove certain triangles are similar by using angle, angle, side, 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 and side, angle, side. We're going to use the triangle similarities to solve the problems throughout the lesson. If you look back in Chapter 4, if you remember when we were doing Chapter 4, we were talking about triangle congruence. Congruence means that the triangles are exactly the same size and same shape, any shape really. And then there were these methods that we use, so side, 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 angle, side, angle, side, angle, 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 side, and then a hypotenuse leg. These were to prove congruent. Today we're talking about similarity, so same shape but not necessarily the same size. Please make sure that you pause the video and write your essential question. Okay, the first postulate is the angle-angle similarity, and this just says if you have two angles in your two different triangles that are congruent, then that means your triangles are similar. So two angles that are congruent, you have similar triangles. Your directions here are to explain why the triangles are similar and write a similarity statement. So I have angle A congruent to angle D, and I have angle BCA congruent to angle ECD because they're vertical angles. So if I have two angles of these two triangles that are congruent, then by the angle-angle similarity, I can say that these two triangles are congruent to each other, or excuse me, not congruent, similar. The two triangles are similar to each other. Next two theorems are side, 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 and side, angle, side. This theorem says that if all three corresponding sides, are proportional to the three sides of another triangle, then that means that they're similar. Not that they're congruent, but they need to be proportional. Side, angle, side talks about a proportional side, an included angle that's congruent, and then another proportional side with the same proportions on both of them. So your second example, we need to verify that the triangles are similar. And this is similar to something that we've done in class where the triangles are a little bit either flipped or turned. They're drawn differently, so we need to figure out which angles are congruent to each other. And this tells us what those are. So P and S are both the first angles mentioned. So P and S are the ones that are congruent. There's P and here's S here. So Q and T are also the congruent angles. T and Q are right here. So that means this triangle is flipped upside down. To help me solve the problem better, I would redraw the triangle with P in the same corresponding spot as S, R, and then Q up at the top. That means this is 2, and these two legs here are 3. Now, to verify that my triangles are similar, I have all my side lengths, so I need to check to see if the side lengths are going to have ratios that are the same. If I have the same ratios, then I can conclude that my triangles are similar. So I have PQ to ST, PQ to ST, which is going to be 3 over 4.5. And that is going to reduce to 2/3. Then I can say QR to TU, QR to TU, and QR is 3 and TU is 4.5. You can see that there and there. And that again is going to reduce to 2/3. The last side, or last group of sides, are PR to SU. PR is 2, SU is 3, so that's 2/3 as well. Now, if you'd like to try this on your own, take a look at number 13 on page 475, and you can do a problem similar to this. Since it's an odd number, you can look up your answer in the back of the book to see if you did it correctly. This is example 2B. Again, we're verifying that the triangles are similar. I have I have two angles labeled, and I have two sides, and the angles are included. So I'm going to check to see if I can use side, angle, side to verify that they're similar. So angle D and angle H are congruent. Angle D and angle H are congruent. I have side DE to HJ. And I had to write HJ, not JH, because D and H are the angles that are congruent. DE is 2 and HJ is 1, so that means that 2 is my ratio, or 2 over 1 is my ratio. And then I can also compare DF to HK. So DF to HK. DF is 5.8 and HK is 2.9, which also ends up equaling to 2 and 9/10 times 2 gives me 5.8. So I have two sides and an included angle. These two sides have the same ratio, and the included angle is congruent. So by side, angle, side, I can verify that these triangles are similar. Here's your last one. We need to find the lengths in the triangles, and we're given these two. There are two triangles here. There's the one that includes the other. First, I need to prove that they're similar. So they both share this angle A, and because they both share it, it's congruent to itself, reflexive, and both of them have a 90-degree angle. So by angle, angle, I know that they're similar. Now I need to find CD. So I can say that AB over AC. AB is 9. AC is 9 plus 3. And that ratio is going to be the same as AB was a smaller one. EB over DC, and EB is 5 and DC is X. So then I can use cross products to find my answer. I have 9 plus 3, which is going to give me 12, and then the 5x. I have a 9x equal to 60. Divide both sides by 9, and I get x equals 60 divided by 9, which gives me x is equal to 6 2/3. Either one of these is an acceptable answer. I'm okay with improper fractions. If you have any questions, please make sure that you write them at the bottom of your notes page. Don't forget to write your summary and include all of the new information. It's also a good idea for you to make connections between the current section that we're working on and past sections that we've already talked about. So if you can draw any connections from stuff that we've already talked about and stuff that we're talking about in this lesson, that would be best.